Okay, so today we're going to start chapter 1. We are skipping over 1.1. It's just got a little bit of prerequisite knowledge. If you want to read through section 1.1 in your e-textbook, you can. Technically, this lesson, solving linear equations with one variable, is still Algebra 1. But we are going to cover it because we will be using the process here of solving equations. So, steps for solving an equation when you have one variable. Our goal is to isolate the variable. Now, we will have special cases, and those special cases are going to be no solution in all real numbers, and then we'll also have one solution. So if the left and the right side of the equal signs are equal, then the answer was going to be all real numbers. When you get this, or if everything cancels away and you're left with a true statement, then that's when it's going to be all real numbers. You might have learned this as infinitely many. In WebAssign, when this occurs, you're going to be typing in reals. So capital R, capital E, capital A, capital L, capital S. So when the two sides of your equation are equal, then the answer is all real numbers or infinitely many solutions. If the variable cancels out and what's left is a false statement, then the answer is no solution. And in WebAssign, you're going to type in DNE, does not exist. This is all explained in the questions. So when you get these answers, make sure you read how they want you to type it in. But I just told you. So if you're left with a false statement, for example, 2 equals 5, which you know will never ever happen, 2 will never equal 5, that's a false statement, so that would be a no solution answer. So just read the instructions on how they want you to input your answers. So let's try some examples. All right, so the first problem has 3x minus 6. We want to isolate the variable x. So what I'm going to do is use my inverse operations. We're working backwards at PEMDAS. I don't know if your middle school teacher or your Algebra 1 teacher taught you PEMDAS is this way, P-E-M-D-A-S. Backwards of it, they might have done SAD-MEP or SAD-MEP, however they want to do it. They might have drawn this crazy little character, like I used to draw this, where it's this, make this for the i's, the multiplication and the division, and then down here will be the adding and subtracting, and that's like his frown. So what you would do is you're going to add or subtract first, so this is this character. You add or subtract first, then you multiply or divide, and then you could maybe put parentheses as his eyebrows. But this is my little character of SAD-MEP or SAD-MEP, where you're going to add or subtract first, then multiply or divide second, and then go back. So for example, in this problem, my first step is going to be to get rid of the 6. So I add 6 to both sides, and I get 3x equals 6. Then my next step would be to do the multiplication or the division, and in this case, it's divide. And then you get x equals 2. And that's how you would solve it. Remember, once you get your answer, you can take what x equals and you can plug it in and see if it works. So you can do a check, and this is optional. So you could check your answer by taking the original problem, taking out the variable x, replace it with what you just found, and then follow order of operations now. Multiply, then subtract, and 0 equals 0. So I did get the correct answer because when I plugged it back in to check it, I did get the true statement. If you would have gotten something like 1 equals 0, then you would have known that you did something wrong. The next one now, I have both variables and numbers on both sides. Now, it doesn't matter what you start with. I'm going to go ahead and move my x's together first. So I'm going to decide to subtract the 3x from both sides. You could have also moved the 4 Or you could move the 5 to the other side, doesn't matter. And then I'll do 5x minus 3x, drop down the rest of the problem, and now I'll move the constants together. So I will now subtract the 4, and then now I'm left with 2x equals negative 12, and now I divide, and x equals 6, negative 6. Watch your signs, okay? And again, remember, you can take this and plug it back in. So if I did the check on this one, I take my original problem, replace both of these x's with negative 6. So 5 times negative 6 plus 4, and then 3 times negative 6 minus 8. Negative 30 plus 4 gives me negative 26. And then over here, negative 18 minus 8 is also negative 26. This is a true statement. So by substituting it back in, I found that I did get the correct answer of x equals negative 6. Again, this check is optional. If you have time to do it, by all means do it. Let's try the next one. Again, I'm using my inverse operations. I need to get the variable and isolate it. So my goal is to get this x to be all by itself. So I'm going to move the 7. So I'm going to subtract 7 from both sides. Now watch what happens. The negative x drops down, and then 19 minus 7 is 12. Now I never ever want to leave a negative variable, so I'm going to divide both sides by negative 1, and I get x equals negative 12. And again, you still have the option of plugging it back in. Number 4, same thing, 2 steps. I'm going to add or subtract first. So I will be subtracting the 2 to work on isolating the x. 23 minus 2 is 21. Divide by 7, and x equals positive 3. Now, I know this is simple stuff. When you're doing the WebAssign, I need to see the work. So you need to be showing work for all the problems and then turning in the work into Canvas to get full credit for the homework. Let's try the next one. Variables and numbers. And again, it doesn't matter if you move the constants first or the variables. I'm going to go ahead and move my 2x to the other side by adding it, so it cancels it out from the right side. So 5x plus 2x is 7x. And now I'll subtract the 3. And 7x equals 3. And now I divide. Your answers can be fractions. So when you're doing the WebAssign, if it says to leave your answer as a simplified fraction, you would enter it in as 3/7. If it says to enter your answer as a decimal, they would expect you to divide it. But more than likely in this homework, they will accept the simplified fraction. The last example on this page. Again, my goal is to get x by itself. So I'm going to be subtracting 7 from both sides. Then negative 2 will drop down, negative 2x. And then I will subtract 15 minus 7. I get positive 8. And now, to solve for x, divide both sides of my equation by negative 2. And my final answer, positive 8 divided by negative 2, is negative 4. So up until this point, all of the examples I just did had one solution. So we're going to have 3 different scenarios. You're either going to have one solution, what x equals, or it'll be all real numbers and you'll type in reals, or it could be no solution and you're going to type in DNE, which stands for does not exist. Try some more examples where it's going to be a single one answer, one solution. So number 7, same thing. We need to get our variables on one side of the equal sign and our constants on the other. It doesn't matter which you move first. I'm going to go ahead and subtract the 5x first. So subtract 5x from both sides. It will cancel it on the right side. And now I'm left with 2x minus 9 equals 7. And now I need to move the 9. And I'm going to cancel it from the left by adding it to both sides. It gets rid of it from there. And now I'm left with 2x equals 16. And now my final step, use the division property of equality, and x equals 8. Now the next one, I need to distribute before I can start moving things. I'm going to distribute and combine like terms first. So for the first thing I'm going to do is distribute the 6. So I'm going to distribute to the x and to the -1. And then I'm going to drop down the +4. Next, I'm going to distribute the 3 to the 7x and to the +1. And now I'm going to combine like terms first. So I have like terms right here with the -6 and the +4. So now I'm left with 6x minus 2 equals 21x plus 3. Now I can start moving my variables together and my constants. It doesn't matter which way you move it. Now, if you noticed all the other examples when I worked it out, I always had moved my variable to the left. You don't always have to move it to the left. You can also move it to the right. So if I wanted to move the 6x over to the 21, I can do that. And then now I'm left with the -2 equals 21 minus 6 is going to give me 15x plus 3. And now I need to move the constant. So I'll subtract the 3 because I need to move it away from the variable. Your goal is to isolate the variable. And then you're left with -5 is equal to 15x. Go ahead and move it up here. So -5 equals 15x. Remember, whenever you're solving for the variable, you're always dividing by that coefficient. So I'm dividing both sides by 15. And now I'm left with -5 over 15 equals x. And now I have to reduce that fraction. I can divide the numerator and the denominator by 5, and it'll reduce to -1/3. So for the next one, same exact thing. We need to distribute first. So I'm going to distribute the 4 to the x and to the 2. 4x plus 8. I still have the -12. And then on the right side, I'm going to distribute the 5 to the x and to the -6. Before I begin using my inverse operations, I need to combine my like terms. So I have like terms here with the 8 minus 12. So this will give me 4x minus 4. And then I still have the 5x minus 30. And now I can begin my solving process. Now, just to show you, I can move the 5. I'll end up with a -x, but that's okay. If you prefer to move the 4 so you don't have a negative variable, that would save a step. But I'll go ahead and show you, you can do it this way as well. And then now I need to add the 4. And then I get -1x equals -26. I cannot have a -x variable, so I'm going to divide by -1, and my final answer is x equals +26. All right, so for the next one, be very careful on this right side here. What we need to do is, you can think of this negative sign, you could think of this as a -1 that you need to distribute, or just know that you're going to distribute that subtraction sign to both. So I'm also going to distribute the 3. So on the left side, I get 3 times 2x is 6x. 3 times negative 4 is negative 12. I'm going to drop down the 7. Then I'm going to distribute that negative sign or multiply it as a negative 1. And now I'm going to look for my like terms to combine before I start my inverse operations. Notice I have a positive 7 and a negative 5 that I can group together. So I have on the left side the 6x minus 12. And then on the right side, I have 2 minus x. And now begin your combining process. I'm going to go ahead and add the x. And I get 7x minus 12 equals 2. Move the 12 now. 7x equals 14. And then divide by 7. And you get x equals 2. And again, on any of these problems, I only had at the beginning done the check. But remember, all of these problems, whenever you're solving for a single variable, you can always take it and plug it back in and see if it works. The next one, same scenario. If it helps you to assume that this is a negative 1 here that you need to distribute, then do that. So for the first part, I'm distributing the 4. So 4 times negative 2x gives me negative 8x. 4 times 1 gives me 4. Drop down the 6. Distribute that subtraction sign, or think of it as multiplying by a negative 1. And then you get negative 2x plus 4. Again, we're going to combine our like terms first, and then we'll begin our inverse process. So negative 8x plus 4 stays. And then combine your like terms. 6 plus 4 is 10. And then minus the 2x. Now begin combining your like terms here. I'm going to move. Again, you can move. Let's move the 8 to the other side. I know I've been always moving it to the left, but you can move it to the right. It doesn't really matter. So then it cancels out from here. And then you're left with 4 is equal to 10 plus 6x. And then from there, move the 10 now and get negative 6 equals 6x. And then divide by 6. And negative divided by a positive gives you a negative 1. Again, it doesn't matter which way you move your variables or your numbers. Just remember, your goal is to get variables on one side of the equal sign and the constants on the other. Now, I'm going to show you a really cool trick to get rid of your fractions. Now, you could distribute the 1/5 to the 2x and to the 5, but you'll be working with a fraction. What I like to do is clear the fraction. So what I'm going to do first is multiply both sides of my equal sign by a positive 5. So if I multiply this by 5 and this by 5, it cancels the fraction, and now I'm left with 2x plus 5 on the left side. I actually have to distribute the 5 to just the numerator, because really it's 5 over 1. So I'll multiply it to the x and to the 2. It still has that 3. And now I'm going to get rid of the 3 that's in the bottom. You could have multiplied the whole thing by 15 and done it in one step. But just to show you, multiply it by 3. It cancels that side. And now distribute the 3. 6x plus 15 equals 5x plus 10. Now I'll begin my solving process. Subtract the 5x. I get x plus 15 equals 10. Move the 15 by subtracting it. And x equals negative 5. Now, you could have distributed the 1/5. It works as well. but it makes it a lot easier if you get rid of the fractions. Okay, so for number 13, same scenario, I got a bunch of fractions here. Now, instead of doing each one individually, what I'm going to do is find the common denominator between 3, 2, and 4. And that LCD is going to be a 12. What I'm going to do is multiply each one of these fractions by a 12. I'm not trying to make a common denominator, I'm trying to get rid of it. So what I'm going to do is multiply this fraction by 12 over 1, this fraction by 12 over 1, same thing here, and then same thing here. So when I do the first one, notice what's going to happen is I'm going to simplify diagonally and make this 12 divided by 3 and it becomes a 4. So now I'm going to be distributing 4 to the 2x plus 4. Next, I'm going to do the same thing on this one. I can simplify, change the 2 to a 1, and change the 12 to a 6. Or 12 divided by 2 is 6. And then I'm going to multiply it to the 1x, so I get 6x. Then the next one, same thing, we're going to simplify that. And 12 divided by 4, this now becomes a 3 that I multiply to the 1x. So then equals 3x. And then lastly, same thing here, simplify. 12 divided by 3 is 4. So I need to multiply 7 times 4, and I get 28. I need to distribute the 4 here, and this gives me 8x plus 16 plus 6x, just rewrite the rest of the problem. And now I don't have any fractions to deal with. They're all gone. So now I'm going to combine like terms first before I begin my inverse solving process. So 8 plus 6x is going to give me 14x plus the 16 equals the 3x minus 28. Let me go ahead and come over here to the side so I don't cram all that in there. So let me just rewrite this. So the 14x plus 16 equals the 3x minus 28. Now nice and simple, same thing we've been doing. Get your x's together, get your constants together. So subtract the 3x. I end up with 11x plus 16. Subtract the 16. Both of my numbers are negative, so I'm going to add and keep the sign. I get negative 44. Divide by 11, and x equals negative 4. Coming up in a different section of notes, we're going to see some problems where they have decimals in them. You can choose to work with decimals by just leaving them as is, or you could also maybe multiply it to move the decimal point. But in this case, since I have a fraction and a decimal, and that fraction, its decimal equivalent is 0.6 repeating. So I don't want to make them both decimals, because if I just put 0.6, I will get the wrong answer. So instead, I'm going to change that decimal to a fraction. And then I'm going to multiply by the common denominator. So the fraction equivalent for 0.25 is 1/4. So I'm going to change the 0.25x and make this 1/4 x. And then now I'm going to multiply my entire equation by my common denominator. And again, same as the problem before, the LCD between 3 and 4 will be 12. So I'm going to multiply each one of the fractions by the 12. Even the other side. So then the first one will simplify. 12 divided by 3 is 4. And then 4 times 2, 2x, is going to give me 8x. I'm going to write it over here to the side. Then the next one, same thing. 12 divided by 4 is 3. So then this one becomes 3x. Over on the other side, nothing simplifies. So I'm just going to multiply the 12 and the x, and I get 12x, and then the 12 and the 2, and get 24. Now I can begin my solving process. Now I need to combine my like terms first. So this will become 11x, and then 12x plus 24. And now I need to get my x's together. So I'll subtract the 12x, and I get negative 1x equals 24. I don't want a negative x, so divide by negative 1, and x equals negative 24. 15, I got parentheses and brackets, so I need to work from the inside out. So I'm going to go ahead and distribute the subtraction sign inside here. So again, think of this as a negative 1 that you're going to distribute. So I'm going to put the 4 in the bracket, the 2x. Going to go ahead and multiply that inside parentheses by the negative 1. And now I'm going to combine my like terms within that bracket. So the 2x and the x become a 3x. And then the negative 3 and the 5 become a positive 2. Still have the 4, and still have the negative 7x minus 2. I now need to multiply or distribute the 4 to the 3x and to the 2. This is where it's going to be very important that you're writing nice and neat and not taking any shortcuts. Otherwise, you may forget some steps. All right, so now I got similar problem to what we did at the very beginning. Let's get our variables together. I'm going to add 7x to both sides. I get 19x plus 8 equals negative 2. Subtract the 8. 19x equals negative 10, and then divide by 19. Notice this fraction cannot be reduced, so this will be my final answer. And again, you can have fractions as answers. So here's our special cases. So again, what I'm going to do is distribute, combine my like terms. So distribute the negative 2. Combine my like terms. So I have like terms here with the negative 2x and the 3. That'll give me positive x minus 8. And if you can recognize that the left side of your equal sign is exactly the same as the right side, then this is going to be the infinitely many solutions, or the all real numbers. Let's say you didn't catch it, and you decided, let me get my x's together, and you end up with negative 8 equals negative 8. At any point, this is a true statement, this is a true statement, and you can stop and type in that the answer is all real numbers. And on WebAssign, you're going to type in reals in caps. You could have even, subtracted the 8 or added the 8, and then get 0 equals 0, it's still a true statement. So, but as soon as I recognize that you have an identity situation, that you have the same thing on the left as the right, stop, and the answer is all real numbers. Let's try number 17. Again, distribute, combine your like terms if necessary. So 3 times 3x is 9x, 3 times negative 1 is negative 3. And then begin your solving process. If you want to try to move your variables first. Now, these special scenarios are going to happen when the variable cancels out. When the variable cancels out, if you're left with a statement that is false, negative 3 will never equal positive 7. This is the no solution scenario. That's the symbol for no solution. However, on WebAssign, you're typing in D and E. The answer does not exist. There is no value of X that would ever make that statement true. On a SAT, you might also see them write out the word no solution. So be able to recognize the no solution, the circle with the slash, the words, but for WebAssign, it's DNE. Now, also on an SAT, instead of them saying all real numbers, they might also say infinitely many solutions. But again, for WebAssign, you're typing in reals. This is also the symbol for all real numbers. It sort of looks like like a capital R with an extra line down it. All right, 2 more examples, 1 more of each. Again, you're going to distribute, and you're going to get negative 12x minus 6, and then distribute the negative 3, and then equals the right side, the negative 15. Let me make it bigger here. Negative 15x plus 1. I need to combine my like terms. I've got a negative 12x and a negative 3x to combine, which gives me negative 15x, and then the negative 6 and the positive 12, and I get positive 6. And now when I try to group my variables together by adding the 15x to both sides, notice it cancels on both the left side and the right, and you're left with 6 is equal to 1, which will never happen. So no solution, WebAssign, DNE. And then one last one. Now, you could either, in this case, I would probably just go ahead and distribute the half, because notice both of the numbers I'm distributing it to are even numbers. So analyze the problems instead of trying to clear the fraction on this one. I could distribute this, and when I distribute, if I take half of 6x, it's 3x. Half of 14 is 7. This one wasn't bad. Work with the fraction. It's totally up to you. And then distribute the 2. Combine your like terms. X and 2x is 3x. And then the 1 plus 6 is 7. And now if you notice, both the left and the right side, these are exactly the same. So when this happens, your answer is all real numbers. So in WebAssign, you're going to type in reals. Again, the symbol for all real numbers, you could do a capital R with a line through it. You could write out the word all real numbers. But remember, for WebAssign, you type in reals.